you make this no solution? Which side would you start on first?
First, you have to do whatever.
Your right, your left, or your right?
You do the right because it has 3 boxes.
Yeah, you do the right because it has 3 boxes. Hey, you need to be quiet. Shh. They can't even hear me record if you're talking over me. Okay, so you do the right because it has more boxes. So give me numbers to fill in those boxes.
3,
3,
7,
7.
6.
Okay, 6. Sounds good? So we work on that side first, right?
Yep.
So 3 plus 7 parentheses x minus 6. And that gives you 3 plus 7x minus 42, right? Combine the like terms. You get 7x minus 49, right? So to make it
49.
39, thank you.
Wait.
That should have been 39.
Oh, I thought it was 42 plus 3 is 45.
It's a negative. Negative 43, right? So that's a negative 39.
That means it's plus 39.
Negative. Which number's bigger? Yeah.
The 3.
No. If there was no negative. If this wasn't there, which one was bigger?
42.
42. The bigger number always takes a sign. Okay? So that's why it's a negative 39. Got it? Or a minus 39. Means the same thing. Now we're going to make it no solution first, right? So I'm going to put here no solution. So we're going to make it no solution. What's nice about no solution is it doesn't matter what the constant is. So on your test, you may need to remember, hey, shh. You need to remember that this is called a constant, the one without a variable. That the coefficient here, the one next to the variable, has to be the same, right? So in this case, the coefficient has to be 7x, 7, with that variable x. And then I don't care really about the constant with no solution. It can be anything I want. So it could be, so this is 7x plus 1,000. Okay? So that will make it 7x plus 1,000 here. Okay, and if you, just to prove it, it's no solution, we go further. We minus 7x minus 7x. Okay? 1,000 does not equal to negative 39. That makes it no solution, right? Okay, now we need to make it infinitely many, infinite solution. For it to be infinite solution, do you want to stick with the same numbers or a different one?
Different numbers.
Okay, let's go with different numbers. Okay, what do you want?
3.
3.
Negative 1.
Let's stick with easy numbers. 3,
1, 2,
and 2. Okay, so if that's the case, you get 3 plus 1x minus 2. If we distribute the 1, did it change our variable any? Our coefficient? No. That gives you still 1x, right? Minus 2, right? 3 plus. Which one would we combine here? The 3 and the 2. Is that a negative or positive 2? Negative 2. So a positive 3 and a negative 2 gets you a 1, right? So 1x plus 1. Okay. So the other side now, we know to be infinite solution. What do we know about the coefficient and the constant?
That they have to equal the same.
They have to be exactly alike. Very good. So if this is a 1 and this is a 1, we need to make sure that up here on our boxes, that's a 1 and that's a 1 also, right? So we need to make sure that has to equal to 1x plus 1 all the way down. And that's all right. And we can prove that it's infinitely many by subtracting 1x, subtract 1x. That's 0, 0, 1 is equal to 1. Right? Now explain the difference between the two. So what do we know about no solution? What's different between them?
That infinite goes like it could go into any. Wait.
Look at the problem. Infinite is the same, has to have the same coefficient. The number next to the variable has to be the same. And what else needs to be the same? And the constant. The constant has to be the same. Is that so? You need to write that down. For infinite solution, the coefficient, in this case, what is the coefficient? Of 1 and the constant. In this case, the constant is the constant right here. Also, the constant of 1 also is the same on both sides of the equation. It's the same on both sides of the equation. Okay? So what's important is kids need to remember, you need to tell me that you know what a constant and what a coefficient is when you're writing. Okay? That's where kids forget all the time, is identifying the number. Yes, Michael? Oh, it's also, what did I forget? Oh, I forgot. Thank you. The same on both sides of the equation. How about what makes while no solution?
They don't have to have the same constant and coefficient.
No, the coefficient has to be the same.
Oh wait.
The constant has to be different. While in no solution, the constant has to be what? Different, right? So in our example, right up here, notice the constant is 1,000, so we get 1,000 here, and this is negative 39. You see that? The constant has to be different on both sides. Of the equation. In this case, it is 1,000 not equal to negative 39. These are our constant. The 1,000 is our constant, negative 39 is our constant. So they're different, right? I don't have enough room, this thing, but you need to state that the coefficients are the same.
Luis Hernandez to the student office.
So this one here, okay, this one I wrote it right this time. Tommy gives baseball cards to 4 of his friends. He gives Justin three cards less than he gives Michael. Okay, so we got Justin.
Michael X.
Michael. Do we know any information on Michael? No, so Michael has to be X then, huh? So I'm going to write Michael first because I like my X first. Michael. Then Justin. He gives Jesus 7 cards more than he gives Justin. So there's Jesus. He gives Willa twice as many as he gives Jesus. Yeah, Monty got cut out. Okay, that's all the friends he have, right? Okay, we don't know anything about Michael, so Michael gets the X. Justin, though, Justin is 3 cards less than
X and X minus
Michael,
three.
so X, that's X minus the 3. That means to flip. This is 3 minus, so it's Michael minus 3. Jesus is 7 cards more. More is plus than we flip. So Jesus, it's plus 3. Okay? Jesus. More than he gives Justin. So Justin, so whatever Justin is, goes there. So what's Justin? X minus 3, huh?
X. Justin.
No, hold on. Oh, this is 7. Why did I write 3? 7 here. 7 more than he gives Justin.
So X minus 3 plus 7.
Yeah, so this here for Justin, X minus 3. Oh, we can combine the like terms here, couldn't we?
Yeah.
To X plus 4. You understand why it's a 4, right?
Yeah.
Because that's a negative 3, isn't it? Okay, that's Jesus. Willa is twice as many as Jesus. Twice is 2 times, right? 2 times Jesus. So 2 times Jesus. Jesus is X plus 4, which we would need to distribute 2X plus 8. Okay? How many cards does Tommy gives to each friend if he gave out a total of 74 cards? Okay. So we need a total 74 cards. All together. So we got Michael plus Justin plus Jesus plus Willa. All that. Combine like terms. We get these, the X are the same. That's 3X, 5X. And the negative 3 and 8, that's a positive 5. Equals to 74. Okay, minus 5 minus 5. 69 equals to 5X. Did I do something wrong? Did you guys get a fraction on number 2?
No.
I got 13.
Yeah, did I do some? Oh, I forgot the plus 4. Plus 4, right? So that should have been not 5, but 9. Minus 9 minus 9. See how I got a fraction? They can't get a fraction of a card. They can't have half of a card. So I know my math, I did something wrong. Because he's giving them cards. So you can't tear a card in half. 65, right? Divide by 5, divide by 5, you get 13. 13 what? 13 cards. And the card belongs to, 13 cards belong to Michael, right? So Michael will get 13 cards. Justin is 13 minus 3, which is 10 cards. Bye. Have a great day. Jesus is X plus 4, so it's 13 plus 4, which is 17 cards. And then Willa is 2X plus 8, so that means it's 2 times 13 plus 8. That's 26 plus 8, which makes it 34 cards. You add up all the cards up and make sure it equals to 74, and that should be correct. Okay, do you understand? Setting it up is crucial. All right? Okay, now the next one here on number 3, this is where a lot of kids mess up. This is like the question I like to put on test. on number 3. I'm going to clear this up so I can show you better. All right. What you need to do is find the least common denominator, right? Which is 6. If you choose 3 and you have a denominator left, then you didn't choose the right one. So times by 6. Okay, I'm going to do this because this is a whole term. I'm going to only times 6 to that fraction there. This whole thing is one whole term. But I'm not going to times the 6 to everything but the number outside. Okay? This times 6 here, times 6 here. Cross cancel. That's a 1, that's a 2. That gives me a 4. 2 times 2 is 4. Now, everything else inside C plus 9 stay the same, okay? And then 6 and 6 cancel out, you got plus 1. 3 and 6 cancel, that's 2, gives you a 4. Okay, got that? You only multiply these two together, not to the inside. Okay? That stays the same. That gives you 4c plus 36 plus 1 equals to 4. Got it? You understand so far? Okay. Now you add these because they're alike. That's 37. 4c plus 37 equals to 4. Minus 37. That gives you a negative 33, right? Equals to 4c. Divide by 4. 33 divided by 4 is 8, remainder of 1, right? Correct? 33 divided by 4 is 8, remainder 1. With the denominator 4. Don't forget your negative. Okay? The next one on number 4. What's my least common denominator? 8. Right? Least common denominator is 8. So you multiply this term, that's a whole term because it all sticks together, by 8. And this whole term by 8. Cross cancel. That's a 1, that's a 2. That's a 2. And this still stays a negative 3. Okay? Times x minus 5 equals to 7. What do we only multiply the 2 to? To negative 3. Okay, that gives you negative 6. X minus 5 equals to 7. You understand that? You only multiply to the 1 that's there. And now we can distribute. Negative 6x plus 30 equals to 7. Minus 30 to both sides. That's a negative 23 because the bigger number takes the sign, right? Divide by negative 6. 2 negatives makes a positive. So 6 into 23, 3 times? 4 times is too much, huh? 3 times with 18. 18 subtract 23 is what? 5? So remainder 5 over 6. Okay? Oh, thank you. All right. So that gives you, so the most important thing here is right here. Don't only multiply to the outside number, right? Right there. So you guys see that? Only to multiply to the 3, and that's it. There's where I can see kids making mistakes. Okay, the back side. Least common denominator? 7. Least common denominator is 7. So we need to multiply all of them by 7, right? By 7, and this one by 7. Okay? This is easy because it cancels out and leave a 1. And 1 doesn't change anything, does it? That leaves a 1. 1 doesn't change this 2 either. You only multiply to the 2. You only multiply to the outside number. This one here. The 1. Only multiply to this 2 over here. Okay? So 1 is like a safe number to easy. So you get negative 5, 2x plus 1 equals to 2 parentheses x minus 4. Okay, so distribute. Distribute here, that's negative 10x. Distribute here, that gives you negative 5. That's 2x minus 8. Now which one would you get rid of?
2x.
Okay, it doesn't matter. If you get rid of the 2, you're dealing with negative 12x, right?
Sorry.
If you get rid of 10, you're dealing with positive 12x. It's still correct if you work all correctly. But like I say, I hate dealing with negative numbers because I am the one that makes the most careless mistakes. Negative 5 equals to 12x minus 8, right? That's when I was a student, that was my main issue. It's carelessness. So we figure out ways to avoid as many careless mistakes as possible. Okay, that gives you a 3 equals to 12x, right? What would you divide by?
12.
Divide by 12, right? The number next to the variable, always. Okay, right? No matter how big or small, it's always the one next to the variable. Divide by 12. Okay? X then is only a fourth, right?
1/4. Yes.
That's a simplified fraction. Okay, number 6. Ooh, number 6, I'd like to put that on the test too. Oh, number 6. What's your least common denominator?
24.
Oh, we got smaller than that. 12.
Oh yeah.
If you use 24, you can. It will work. It's just, it takes longer, yeah.
I know.
The number gets really big.
Wait, use your least.
Yeah, you use least common denominator, which is 12. Okay? 12. Makes it a little bit harder if you use 24. Okay? Cancel out. So 3. Okay, so this is 3 times 6x plus 1. Do you see that?
Yeah.
This is where some kids get confused here. This is 3 times that, because that's what's left. Okay? Minus, well, cross cancel here. That gives you 2, 10 equals, cross cancel. That's a 3. What do we multiply this 3 to?
4.
The negative 4, right? That negative 4 there. Not to the inside, just only to the number outside, right? That gives you a negative 12, correct? X plus 2, that's left. That, we can solve this, couldn't we? Gives you 18x plus 3 minus 10. That's negative 12x minus 24. Right? But be careful with the negative here when it's here and a positive. It's where kids make so many mistakes. Carelessness like I do. Okay, combine like terms. So Alejandro, I'm sorry. What would this be? Negative 7. Negative 12x minus 24. Which one would be the wise choice to get rid of? 12, right? That would make it, so you add 12 to both sides, 12x. Okay? You understand why, correct? We don't want to deal with negative numbers. Then you add 7. Add 7. In this case, we couldn't help it. And it gives you negative 17. Right? Double check. Add back. 30x. Divide by 30. Can we reduce further? No, so x is just negative 17 over 30. Pretty easy, right? Okay, number 7. What's the least common denominator? 15. Least common denominator is 15. Okay, times this by 15, times this term by 15. Okay, cross cancel. I'll use blue here. That's 3. Okay, you just multiply to the outside only, right? That gives you 6, parentheses, 10x minus 5 equals to cross cancel. That gives you 5. 5 times 2 is 10x. Okay? Now distribute 60x. Distribute minus 30. Okay, which one would we have to? In this case, we got no choice. Well, actually we do. We can make that 10x equal to 0, but we need to keep it equal to 0 though. But I tend to not like that.
Eric Pastrana, please come to the front office.
So which one would you get rid of?
Eric Pastrana, please come to the front office.
Okay. If I got rid of, some students will get rid of the 10x. Okay? Which is fine. If you get rid of the 10x, which is fine. It's best to get rid of the 60. You'll see it better. But if you do get rid of the 10x, you need to put a 0 here. You absolutely need to put a 0. All right? You make the problems longer though. Yes.
Do we still get the same answer?
Yeah, watch. You do minus 60 and I do negative minus 10. Okay? It is best. No teacher will ever teach you this way. It is like evil to do this almost. Because you need to know you're doubling your work. So I'm not going to do it this way, even though you'll get the same answer, 30 over 50, right? And you'll reduce it to 3 over 5. It's the same answer, no matter what you do. But it just double the work, and I don't want to double the work. So I'm going to minus 60x. Minus 60x, because I can get negative 30 equals to negative 50x, and divide by negative 50. X equals to a positive 3 over 5. It's much faster than the other way. And it's just a step faster. One less step, that's all. Okay, the last one, what is the least common denominator? 3. This one is easy, huh? 3, 3. Because it only gives you a 1. I just see it as it being gone.
Wait, what was the answer to the last question?
3 over 5. Okay, so that eliminates that. That gives you 4 still. 2x plus 9 equals to 7 parentheses x minus 6, right? Any questions so far? Okay, so that's 8x plus 36, right? 7x minus 42, right? Okay, now which one would you get rid of? 7. It gives you an x only, or 1x if you want to. But we all know it's a 1, right? So here's where the mistake comes in. This negative 42, you should put a negative 42, not just a 42. Where kids make the most mistake, the negatives. I know, because I do that too. That's like evilness, you know. That's a negative 42. Minus 46, minus 36, sorry. Right? Do we add them or subtract them?
Wait.
Add them, right? Because they're both negatives. So that's a negative 78 equals to x. Oh, we don't even have to divide. That makes it easy. Okay?
You should put this in the test.
them will be, or 2 of them will be on there. 1 and 3. Okay, 1 you make up your own. You want me to go over it with you?
No, it's just I was writing down the explaining part.
Oh, okay. Well, 1 you just make up your own. All kids should be giving me different answers for 1. The explanation is the same or similar, but the problem itself needs to be different.
Wait, Miss Wilcox, is it okay if I put that answer? Because I was the one who put the numbers.
Yeah. No, I'm just saying on a test. I will give you different patterns to it. I may switch it, may give you numbers, more numbers than not.